Hello friends, I am your maths faculty from QLS Academy. We were studying the topic probability and we will continue to study the same in this session. So let us start. I hope you will have fun learning. Now first of all, I want you to know that an event having only one outcome of the experiment is called an elementary event. In the example we saw in the previous session, both the events E, which was of occurrence of heads, and F, which was occurrence of tail, are elementary events. Also in the examples we saw, we noted that P of E plus P of F is equal to 1. In the example with the three different color balls in the bag, we note that P of Y plus P of R plus P of B, that is 1 by 3 plus 1 by 3 plus 1 by 3 is equal to 1. Observe that the sum of the probabilities of all the elementary events of an experiment is 1, always, which is true in general also. Suppose we throw a die once. What is the probability of getting a number greater than 4? And what is the probability of getting a number less than or equal to 4? So here, let E be the event getting a number greater than 4. The number of possible outcomes is 6. 1, 2, 3, 4, 5 and 6. And the outcomes favorable to E are 5 and 6. Therefore, the number of outcomes favorable to E is 2. P of getting number greater than 4, that is equal to 2 by 6, which is 1 by 3. Also, getting a number less than or equal to 4. So here number of possible outcomes is 6 and outcomes favorable to the event F are 1, 2, 3 and 4. So the number of outcomes favorable to F is 4. Therefore, P of F is equal to 4 by 6, that is 2 by 3. If we talk about the coin example, then isn't F the same as not E? Yes, it is. We denote the event not E by E bar. Also, P of E plus P of not E is equal to 1. That is, P of E plus P of E bar is equal to 1, which gives us P of E bar is equal to 1 minus P of E. The event E representing not E is called the complement of the event E. We also say that E and E bar are complementary events. Before proceeding further, let us try to find the answers to the following questions. What is the probability of getting a number 8 in a single throw of a die? Number 2, what is the probability of getting a number less than 7 in a single throw of a die? So for the first part of the problem, we know that there are only 6 possible outcomes in a single throw of a die. These outcomes are 1, 2, 3, 4, 5 and 6. Since no face of the die is marked 8, so there is no outcome favorable to it. That is, the number of such outcomes is 0. In other words, getting 8 in a single throw of a die is impossible. So P of getting 8 will be 0 by 6, that is 0. That is, the probability of an event which is impossible to occur is 0. Such an event is called an impossible event. Let us answer part 2 of the problem. Since every face of a die is marked with a number less than 7, it is sure that we will always get a number less than 7 when it is thrown once. So the number of favorable outcomes is the same as the number of all possible outcomes, which is 6. Therefore, P of E will be P of getting a number less than 7, that is 6 by 6, which is equal to 1. So the probability of an event which is sure, that is certain to occur, is 1. Such an event is called a sure event or a certain event. Note that from the definition of the probability P of E, we see that the numerator, that is number of outcomes favorable to the event E, is always less than or equal to the denominator, which is the number of all possible outcomes. Therefore, P of E is greater than equal to 0 and less than equal to 1. Now let us take an example related to playing cards. Have you seen a deck of playing cards? It consists of 52 cards which are divided into 4 suits of 13 cards each: spades, hearts, diamonds and clubs. Clubs and spades are of black color while hearts and diamonds are of red color. The cards in each suit are ace, king, queen, jack and then 10, 9, 8, 7, 6, 5, 4, 3 and 2. Kings, queens and jacks are called face cards. Now let's solve a problem. One card is drawn from a well shuffled deck of 52 cards. Calculate the probability that the card will, number 1, be an ace and number 2, not be an ace. Now, well shuffling ensures equally likely outcomes. So, for the first part of the problem, there are 4 aces in a deck. Let E be the event, the card is an ace. So, the number of outcomes favorable to E is 4. The number of possible outcomes is 52. Therefore, P of E will be 4 by 52, which is equal to 1 by 13. For the second part of the problem, let F be the event, card drawn is not an ace. So, the number of outcomes favorable to the event F will be 52 minus 4, which is 48. So, the number of possible outcomes is 52. Therefore, P of F will be 48 by 52, which is equal to 12 by 13. Now, the next problem says that two players, Sangeeta and Reshma, play a tennis match. It is known that the probability of Sangeeta winning the match is 0.62. So, what is the probability of Reshma winning the match? Now, let S and R denote the events that Sangeeta wins the match and Reshma wins the match respectively. The probability of Sangeeta's winning is P of S, which is equal to 0.62, it is given to us. And the probability of Reshma's winning will be P of R equal to 1 minus P of S, as the events R and S are complementary. So, we can write this as 1 minus 0.62, which is equal to 0.38. Now, the next problem says that Savita and Hamida are friends. What is the probability that both will have, number 1, different birthdays, and number 2, the same birthday, ignoring a leap year? So, out of the two friends, now Hamida's birthday can also be any day of 365 days in the year. We assume that these 365 outcomes are equally likely. So, for the first part of the problem, if Hamida's birthday is different from Savita's, the number of favorable outcomes for her birthday is 365 minus 1, that is 364. So, the probability that Hamida's birthday is different from Savita's birthday is 364 by 365. For the second part of the problem, probability of Savita and Hamida having the same birthdays will be equal to 1 minus probability of both have different birthdays. So, this is equal to 1 minus 364 by 365, which is equal to 1 by 365. So, friends, this is it for this session. I hope you had fun learning. For any queries information, you may visit the link following the video. Thank you.